Hello everyone, hope you're having a good time. This should be a panel on digital security and basically how to secure your cryptocurrencies. I really honestly don't know what kind of audience here is today. Could you please raise your hands if you're familiar with Bitcoin and cryptocurrencies and you think you know how to secure your Bitcoins? Okay, about maybe a third. Okay, so we'll try to make it understandable for everyone. And if you're expecting some very technical stuff, these two men here are available for you later on to go really into the nerdiness. But I'd like to keep it understandable. I will do a really short round of introductions so you actually know who's here today, and then we'll just continue. So I'll start with myself, if you don't mind. My name is Alena Vranova. I'm a business developer. I'm not a developer of software. I've been developing businesses in the financial industry for a decade before I moved on to Bitcoin in 2010. And I'm probably most known for co-founding Satoshi Labs, which is the company behind Trezor, the hardware wallet. And that was the first actually really secure and let's say foolproof way for people like myself to secure their cryptocurrencies. Today, I'm more into giving back to the community, so I just opened a new foundation that's specifically determined to support research and development in the Bitcoin space.
Hi, everyone. My name is Paul Makowski. I'm working for a company called PolySwarm that I helped co-found and a developer at. Previously, I've worked for the U.S. government and also helped run a U.S. government contractor in the information security space. With PolySwarm, what we're trying to do, and by the way, I'm super happy to share the stage here. We use Trezors all the time at PolySwarm, so this is pretty awesome. This is pretty cool. We at PolySwarm, what we're trying to do is fix the threat intelligence market. Right now, we think that there's a market problem in the antivirus market. Specifically, a lot of antiviruses are trying to solve 80% of the problem, detecting a lot of common Windows malware and not really branching out from there. So we think that's more of a market design problem rather than a particular provider producing a solution problem. So we're looking to disrupt that and change how players in that ecosystem participate by developing smart contracts that hopefully define better forms of interaction. Previously to starting PolySwarm, I worked currently still work nominally, I guess, at NARF Industries, which is a consultancy that has most recently done some work for DHS. In terms of, DHS was concerned about identity management for their own employees, and they wanted to research incorporating a blockchain sort of technology into keeping track of what their employees are, what their employees have access to, et cetera, but do so with confidentiality controls. So not everyone's information is released to everyone that has access to this chain. As anyone that's familiar with a consensus algorithm in a blockchain environment can probably tell you, it's difficult to reach consensus on something that's opaque. So this is a rather fundamental problem that we tackled a bit on behalf of DHS.
I'd like to open the topic with a very general view. I just opened my very, very old 2016 presentation on the digital threats or on the general threats that consider cryptocurrencies. And I was able to basically generalize 5 different risks, potentially, making you lose your cryptocurrencies. The most prevalent risk for your crypto is obviously the digital risk. And I found mind-blowing numbers of unique types of malware. So I found that 2009, experts have been able to pinpoint 2 million different types of malware. 5 years later, it was 220 million. In 2016, it was 440 million unique types of malware. So that just gives you an idea of how much the space of viruses and malware is exploding. And since 2013, when Bitcoin price soared, there was also a huge explosion of specific malware just designed to steal your Bitcoins. Okay, a malware that would crawl through your computer or your phone looking for the wallet dot, which is the file containing your private keys. and or malware replacing your receiving addresses. So you copy paste, and basically it scans your copy paste. How do you call it? The buffer, the memory buffer, and when it sees a Bitcoin address, it just replaces by the attacker's address. And so you're sending Bitcoin, you're thinking that you're sending it to the correct address, but it's not the case. So this is like, and we'll come back to that and talk about whether we think that antivirus works at all or not, and whether you should rely on that. But there are more risks that make you possibly lose your money, such as the third-party risk. And that's so visible, especially in the case of private money. So Bitcoin and cryptocurrencies are designed as private money. It does mean that you should be the sole owner and manager of your cryptocurrencies. And you should be able to do that without having to trust another company, without having to have to use crypto banks. Okay, there's a lot of services in this space. I understand that, but I think we should just stick to the basic principles of Bitcoin, and when we follow the basic principles, we'll be safe. Okay, maybe you guys want to talk a little bit, or even give us your opinion on the third-party risk, how to deal with that. Whether you think it's really necessary just to stick to the private ownership, or how do you see the space there?
Sure. So this is really intended to be pretty open-ended. If anybody has any questions, I think any of us are happy to field them. I prepared a few slides. I guess you see one of them. Do we have it? Okay. So maybe we could do a few more, but yeah, it's really just open-ended here. If you have any questions, happy to answer. I kind of want to just go through just a few to give a little bit of background. Let's see here. So who here has heard of symmetric encryption? Yep, okay. Anybody here done a cryptoquip in a newspaper? That's where you substitute the letters and try to figure out what's happening. It's in the comics section, so I'm sure nobody reads that. Anyway, that's a really bad symmetric cipher. That's a substitution cipher. So symmetric encryption is kind of what came out first. It's old. It's what Caesar used. There's actually an example called Caesar's cipher that he used to encrypt his communiques to his army generals. I forget which Caesar, but there you go. So that the key with symmetric encryption is the necessary information to both encrypt and decrypt is the same information. So moving on. Oh, okay. Who here's seen Christmas Story? Okay. So that's symmetric encryption when Ralphie uses the decoder ring. That's symmetric encryption. So asymmetric encryption is more relevant to Bitcoin, blockchain in general. This is what allows people to send messages, secret messages for specific recipients. If you use Signal or WhatsApp, or if you use a browser and there's a green lock in the upper left-hand corner, you're using asymmetric encryption. It allows Alice to send a message to Bob that nobody else can read, and vice versa. Step 2 is actually getting the public key, in case anybody notices that, but we'll not deal with that. So that's another problem entirely. So that's a little bit about asymmetric. This is probably way too much, but
let's skip that.
Summarizing data, skipping that. You can sign things. So I actually had to get something notarized today, and that's a very old process. It's something that's been happening for thousands of years, and they actually took out a stamp, and they stamped the thing, and okay, that has some sort of security along with it. Actually, it was a Puerto Rican document, so it actually had more security features than a California document, because I did that recently as well, so food for thought. But there's an equivalent in the digital space as well, and this is necessary for things like transferring funds. So we use digital signatures. Yeah, I mean, the rest is kind of jumping into smart contracts, which is a little bit more of an involved sort of topic, but smart contracts on the Ethereum chain is really just programmable money. So if people are curious about some vulnerabilities in that sort of space, here's one example. I'll just do one. Somebody wrote a rocks, paper, scissors game on top of the Ethereum blockchain that allowed people to play rocks, paper, scissors with a 1% juice or cut going to the person that wrote the game. The fatal flaw here was when people played the game and they said, hey, I'm going to say scissors. Their scissors play is currently in flight. It's an unmined block. And so anyone running a full node can see what the other person plays. So if there's a fundamental flaw around a design of a rocks, paper, scissors game, it's knowing what your opponent plays before you get to play. And that's exactly what happened here. But those sort of problems are what can affect smart contracts. So anyway, I'll stop this for a bit because this can kind of get into the weeds. But happy to chat. This one is a legitimate pyramid scheme implemented on the Ethereum network that had a vulnerability in it.
And so just to quickly finish on the topic of a hardware wallet, the way it works is basically an offline computer that in an offline environment generates your private keys. Private keys are basically your passwords to your bitcoins or to your crypto that's on the blockchain. Okay?
Sure. Digital power of attorney, basically.
Yes. Okay, so you have the hardware wallet in a secure offline environment that has a very limited, usually USB protocol that does not allow any viruses to get in. You can easily recover the hardware wallet, so in case you lose it, you don't have to freak out as you freak out when you lose your phone with your bitcoins, okay, or your computer. So this is the idea of a personal security, not of the company security, but there's of course all the companies in the space are using some type of a hardware wallet because that's probably the. What else is there that you can do? Oh, multi-sig. Can you guys maybe introduce the idea of a multi-sig for mutual funds?
Sure. So who here has heard of the concept of a multi-signature wallet? Okay, fair number of people. So a multi-signature wallet can be another sort of access control. It makes sense sometimes, maybe it doesn't make sense in other cases, but in the case where you don't necessarily trust fully everyone that has access to some portion of a key, a multi-signature wallet makes a lot of sense. Particularly in the case where you don't trust users' equipment fully, which really you shouldn't. So there's multiple layers of trust there. I think in general, we've kind of mentioned, we've touched on a lot of different layers of the stack, really, that can be attacked and cryptocurrency stolen, all the way down to replacing a contribution address in memory, to exchange hacks, to attacks on protocols underlying blockchain protocols. There was a recent excellent paper specifically targeted at Ethereum, where Geth prior to 1.8 was very easy to eclipse, is what they called it. Even without the ability to conduct BGP attacks, if you had just 2 IP addresses and some time, you could force a targeted node into a state where they would only listen to you. So you could lie to them about the state of the blockchain. There's attacks at all different kinds of levels, and on the defensive side, I think defense in depth is very important. I certainly don't think anything along the lines of antivirus is a magic bullet at all. I don't think anybody thinks that, but it could be improved over what's currently going on today. But hardware wallets are an excellent tool, and multi-signature wallets have their place sometimes, but if you recall, even them can have vulnerabilities. Parity's multi-signature wallet has 2 very notable, very recent vulnerabilities, and obviously that's developed by some of the foremost developers in the space. So in general, when we're talking to clients, when we're talking to customers, one thing to look for is less code. The simpler, the better. Fewer mistakes can be made in less code, ideally. That's not always true, but yeah.
Do you want to add something more?
No, I think those are great points. It's the whole free software philosophy that with many eyes, all bugs are shallow. It's by reusing code, by using open source applications, we can kind of reduce our risk. I mean, this is kind of the concept, and this is the guiding principle of a lot of the.
I kind of disagree with that. Though.
Yeah, like Open Zeppelin. If you're familiar with Open Zeppelin, they draw on the same principle.
Yeah, I kind of disagree with the all bugs are shallow thing, though.
Well, it's the bazaar versus cathedral kind of thing, right?
Linus has been saying that for years, and Linux has bugs all the time.
So does Mac and Windows.
So does Mac, so does Windows.
Yes. Actually, Apple even having more vulnerabilities, but because of their governance, they're less visible and less actually in play. And there's been numerous hacks of smart contracts. The smart contracts are still poorly written. So I just want to give it, like, say it out loud, make sure that the company you're investing has good audits in place. And if they change something in the code, it goes through the audit again.
On the,
you are Ethereum guys. You are Ethereum guys, so maybe you can say more about it.
Definitely. On the smart contract space, frankly, the state of the art, the state of the science, hasn't advanced far enough to really say a lot of things definitively in a formal manner in terms of formal verification of smart contracts. It's very difficult to do that. It's still an area of active research. Solidity is not very amenable. Solidity is the programming language that Ethereum smart contracts are written in primarily today. It is not very amenable to formal analysis. I joke with my civil engineering friends and even electrical engineering friends that they need a license to practice engineering. And as a computer engineer, I do not, despite possibly writing code that holds millions and possibly billions of dollars. And in some cases, in the case of, this is cryptocurrency related, WannaCry was a big example recently, where North Korea ransomware at a bunch of different places, including hospitals, which actually put lives at risk. It's really interesting that there's really no certification. Well, there's certifications, but there's no license in the computer engineering, computer security realm right now, because we don't know how to do it. But you know, we're doing the best we can, and you know, a lot of money's riding on it. But one big thing that concerns me right now with the Ethereum smart contract space is in general, it's critical to have a path to upgrade, a path to patch. You know, we were talking about Linux, Windows, OS X, they have vulnerabilities all the time, but guess what? They eventually get patched. In the case of the Ethereum blockchain, in case of smart contracts, by and large, they're designed to never be modified because they're supposed to be trustless and stay there forever. If a vulnerability is discovered in them, it's very difficult to patch. There are some ways around that. You could use proxy contracts. Happy to chat with somebody offline about that. But yeah, that's my biggest fear there, and it's kind of interesting how this space is treated differently than the other engineering spaces, frankly.